So for this week, we are going to cover chapter 5, okay, or week 5, where you can see on the you learn on this lecture slide. Okay, so please download that for your reference. Now, let me start with this is network components, right? Okay. Okay, so for this chapter, this is about a network component. So for this chapter, I would introduce about the connector, transceiver, and media converter, and then network interface card, repeater, and then other components that would enable the network, okay, to build up a network in the organizations or anywhere. So in this case, I will just a brief about repeater and hub, bridge, switches, and routers. Okay. Now for the hold on. Okay. Okay. So let me try back again. Okay. Now what I want is the for the laser pointer. Okay. Now, for the communication at the data link layer, okay, so basically the communication, the name of the communication is what we call as hop-to-hop delivery. So the meaning of the hop-to-hop delivery means that the datagram or the packets that we want to send out to the destination, in this case, from Bob to Alice. Okay, so Bob is the sender, Alice is the receiver, right? But in order to send the packet, okay, so first is that they need to know on the data link, the communication on the data link must know what is the next devices or network intermediary devices that it can connect, okay, that can forward the packet datagram. So you have the IP address on your packet, okay, where you have the sender and receiver IP address, but then you need to pass through to a certain routes. Okay, so in this case, sometimes you have an alternative routes, okay, and then sometimes you will use the main routes, okay. So in this case, on the data link, it would determine where is the next devices that they need to hop into. So because Bob is on one company that has the switch that is connected to the ISP, so the next destination should be R7. So inside the data link should contain the MAC address of the R7. And then from the R7, it will check on its on the data link layer where it contain the destination is forwarded to the R7. And then R7 would encapsulate back again and decapsulate and then open where is the final destination which contained inside the network. Okay, so the final destination or the IP address that should be sent out is to Alice. So it would determine where it should go next. So in this case, it should go to the R5. So it would encapsulate back again by replacing the MAC address for the next destination. And then the sender comes from the R7. So then it will send out. Okay, so in this case, this is what we call as hop to hop. So from R7, it hops the datagram sent out to the R5, and then from R5 to the switch one, which would be determines that the next hop should be on R4. Okay, so R4 would determine, oh, okay, my next hop should be on R2, and then R2 would check, oh, okay, your final destination or your receiver should be Alice, which is inside my network. So it will replace back again inside the MAC address that it would send directly to the Alice. So this is what it means as a hop-to-hop delivery. But still, it happens on network from the let's say from one residence or from one building to another buildings, which is on a different network. Okay, so right. So what will be needed um for this communication to happen? So this chapter will explain about the media connector, the media converter, and also the network equipments that commonly used on the basic networks and how it is working. So in this case, I would explain a little bit. I'll just brief because this is what we have covered so far, right? But there's a connection, okay, in between for the connectors, and also to the next chapters about the protocols and standards that we use. All right, so I'll cover a little bit about the UTP, fiber, coaxials, and other connectors. So for the UTP cable, okay, most commonly the connector used is RJ45, or RJ means that registered jack. So it's a key connector, meaning that the connector can be inserted in only one way. The reason is that to lock or to using the crimping, it will lock the positions of the cabling here. So in order for these circuits to be able to connect to the next devices, okay, to the ports. So the connectors feature 8 pins to which the wire strands of a cable interface electrically. So this contains a copper wire inside of it, okay, and then insulated. But the copper has the capabilities to transmit a signal in electromagnetic signal. And then the standard RJ45 pin outs define the arrangement of the individual wires needed when attaching the connectors to a cable. So from one end, maybe this is for the PC, and then another end is connected to the switch. All right. So one way to measure the performance of twisted pair cable is to compare attenuation versus frequency and distance. Um, and then for the LAN in a local area network, okay, such as 10 base T or 100 base T, they use twisted pair cables. Okay, twisted pair cables also is used in the telephone line to provide voice and data channel. Okay, so the RJ11 connectors used with telephone cables, for example, are only slightly smaller or narrower compared to the RJ45 here. Okay, so they use a lesser cable pin to connect. Okay, for the telephone cables. And then the next one is the coaxial cable connector. Okay, so they use a bayonet nail concealment connector, which is a very common type of radio frequency connector used for terminating coaxial cable. So this is the cable that contain inside the coaxial the coaxial cable, and then the connector is used by with a BNC connector. Okay, and then it was commonly used on 10 base 2 thin Ethernet networks, both on cable interconnections and network cards. So some of the network cards, okay, have both. One is for the RJ45, and then this one is for the bayonet nail concealment port. Okay, so this one will be connected to the one end, okay, and then they lock it. Okay, there's a lock here. So to be able to confirm or to attach the cable, okay, from the network interface card on inside your PC to the cable here, the connector, and then from one end will be connected to the hub, okay, to the hub or to the switches, right? Now Sorry. So BNC connector is used to connect the end of the cable to a device such as TV set. In a case in Europe where we use a E1 or T1 there, they use a coaxial cable. Okay, coaxial cable to connect from the PC to the router or to the Wi-Fi router or to the to the modems. So the BNCT connector is used in the Ethernet networks to branch out a cable for connection to computer or other devices. So for the case of Ethernet networks, they use this, okay, BNCT. So the BNC terminator is used at the end of the cable to prevent the reflection of the signal. The coaxial cable was used for digital transmission in early Ethernet LANs, such as Thin Ethernet or 10 base 2, where it uses RG58 coaxial cable with BNC connectors to transmit data at 10 megabit per second with a range of 185 meters. Okay, so the range must be in within 185, and then if it's longer than that, the attenuation will be much more higher. Then fiber optic cable. The fiber optic cable connector terminates the end of an optical fiber and enables quicker connections and disconnections. Okay, using the SC connector or maybe SD connector. The connectors mechanically couple and align the cores of fibers so that light can pass. Okay, so the end of this must be connected to the other end so that the connections, okay, happens. Okay, the channel can be connected together. Okay, so a variety of connectors are available, such as SC, or what we call as a square connector, and then ST as a step and twist. The step and twist is very similar to the BNC. Okay, so generally organizations will standardize on one kind of connector depending on what equipment they commonly use or per type of fiber, such as one for multi-mode and then one for single mode. Okay, other converters or connectors, such as we use RJ45 to DB9. Okay, in this case, this is for connecting to or configuring the network devices. Okay, also we have RJ45 to SC to the fiber, and then DB9 to DB25, like this one. Okay, such applications use is in like a banking for printing, so they sometimes they use this. Okay, and then network interface cards, NIC. Okay, have a different specification. If it's a wired, so then it needs a port for the RJ45 to be inserted. But then let's say you want to use for laptop, so sometimes they do have a network card. Okay, but this one is old. Your laptop at the moment was embedded, right? So your network card for your wireless was embedded on your laptop. Okay, so most probably on very nearest to the camera, okay, or at the top of your lid. So the adapter controls the exchange of information between the network and user. It divided the data into packet and control the data flow. Uh, okay, repeater and hub. Repeater are often used in transcontinental and submarine communications cable because the attenuation signal loss over such distances will be unacceptable without them. So if an engineer, if you want to have like a certificate for a diver, right? So what they do is that they would replace, okay, some of them like a cabling, or sometimes change the repeaters, because these repeaters is planted on inside the sea, okay, at the bed of the sea. Okay, so because of this cable, like a fiber, okay, so they have a maximum distance that they can cover, so they need a repeaters. Okay, But repeaters can have both. They can use in both copper wire cable carrying the electrical signal, such as the UTP that we use so far, and then also the fiber optics that carrying the light. So what are the operations of a repeater is that they regenerate the signal. Okay, where a repeater is an electronic device that receives that signal and then they retransmit it back again on a higher level or using a higher power or onto the other side of an obstruction so that the signal can cover longer distances without degradation. So, but the repeater is a layer 1 where it simply repeats the signal from one wire into another wire. Okay, they are not intelligent. Now, the next one is a hub where the device are used as a central point for connecting the segments in LAN. So usually it operates in layer 1 that contain multiple ports. Okay, so there's another version that we call as a the name other versions that we call for the hub is multi-port repeater. Okay, so in this case, they upgrade, okay, they improvise the repeater so that it can become a multi-port hub and also, okay, has the functions as a repeater. Using a hub, okay, basically means that they deploy the star topology. Okay, so it's the same as the repeater. It's a layer 1 devices. So next is that how does a hub operates? When a signal arrives at one port, it will be copied to the other ports. The hub will copy it to other ports and then broadcast it. Okay, so the encapsulation process is the signal. So the hub functions as the central connections point of a network. It would join other workstations, printers, servers on the network so that they can communicate with each other. Each hub has a number of ports that connect it to other devices via network cable. So a hub is an inexpensive way to connect devices on a network. It's very cheap. Okay. And then the data travels around a network in a packets and a hub forward these data packets out to all devices connected to its ports. So as a hub redistributes packets to every device on the network. So when a packet is destined for only one device, every other device connected to the hub would receive that packet. Remember, as I said before, it's a broadcast, right? So every other devices except for the sources will receive this packet. Okay, because all the devices connected to the hub are contending for the transmission of the data, the individual members of a shared network will only get a percentage of the available network bandwidth. So, let's say for a hub, if you have like for a bandwidth of 10 megabits per second and then you have 4 ports, then it will be shared together in between um the devices. For example, a 10BST hub Ethernet hub provides a total of 10 megabit per second of bandwidth, which all users would share. Let's say if one person on the network is downloading a very large file, for example, like a video, okay? So little or no bandwidth is available for other users. So these users will experience very slow network performance. Now, a network bridge connects multiple network segments at the data link layer of the OSI model. So let's say you have a big lab, okay, that is shared together. Okay, so you want to connect a very one or two labs or one or two LANs. Okay, so sorry, not one or two LANs. One LAN that is traversing to another distance. So we need to connect to several network segments. So using network bridge would connect these small networks, okay, to become a bigger network. So but this bridge would divide the segments into a smaller LAN to reduce the traffic, remember? So because we are using like a 10 base T, okay, so they are sharing the bandwidth, right? So to ensure that there's no to reduce the slow or the reduce of the network bandwidth, so then they come out with the network bridge. So the network bridge here, okay, because we are using a long backbone of a cable here, so they use a bridge to divide it into a small segments. So the bridge would monitor the packets and keeping track of the MAC addresses. So bridge is under the layer 2. So the bridge uses MAC addresses to handle the traffic flow. A bridge can also filter by MAC address, a feature that makes the bridge more attractive than a repeater. So this style of filtering on Ethernet is what we call as transparent bridging. A switch is like a hub that acts as a central point to connect nodes and have multiple ports. It is much more faster and intelligent than the hub and bridge. And also, it's known as a multi-port bridge. Remember, the multi-port bridge is to connect small segments, right? So it connect to a different segments. So switch is a better versions of the bridge. Okay, so it has a multi-port bridge compared to the bridge here. It connect very few network segments. Now, switch operates in layer 2. Okay, means that they need to forward the packet based on MAC address. So it operates using a layer 2. Layer 2 switch is essentially a super bridging device. Instead of connecting via interfaces, the connection medium of a switch is a port. Just like a port on a simple hub, like a repeater. Okay, so they use a port to connect in between the switches to another network devices. Unlike a hub, a port on a switch can be configured to belong to a specific network, okay, such as like a VLAN. Okay, so as you can see in this figure, okay, we have like a network topology, but it contains a different LAN using the concept of VLAN. What is a VLAN? VLAN is a virtual bridge that segments a physical broadcast domain inside of a switch. So for a certain ports, okay, they belong to a specific VLAN. So the broadcast domain only, the packet will be broadcast to that same domain because they are belonging to the same VLAN. Okay, for example, if the packet is for VLAN manufacturing, then it will be broadcast to the manufacturing VLAN only. The rest will be filtered out. Okay, they will not be sent out to that different VLAN. So the rule of thumb is that one VLAN cannot explicitly pass traffic to another. So if it's meant for manufacturing, it will not be sent out to the finance and server farm. Okay. For example, finance traffic is now kept inside the finance token ring and Ethernet networks. And then manufacturing has its own VLAN extended across an ATM LAN link. This is a very good solution for managing the bandwidth. So the point that needs to be made is that layer 2 switch will provide the ability to carve up your network into broadcast domain, because using a VLAN would decrease the size of the broadcast domain. So if you are not sure what is a broadcast domain, you can Google it. What is a broadcast domain? A broadcast domain is the area, okay, of where we broadcast the packet. So if there is a congestion, okay, the bigger the size of the domain, the higher it is, the congestion would happen. Okay, so the best is that we decrease the size of this broadcast domain, okay, by using the VLAN. Okay, so to make this broadcast domain share traffic, because they separate, right? Okay, but sometimes they need to communicate with another VLAN. So what they need is that they need to share traffic using a layer 3 switch, or what we can use another version is that we call as router. Okay. Now, what are the benefits of using VLAN? It will increase the performance because we create smaller logically partitioned broadcast domain that will decrease the overall network utilization. Okay, and then sending broadcasts only when they need to be sent, thus leaving more available bandwidth for the application traffic. And then it also decreased the cost. Historically, broadcast segmentation was performed with routers, requiring additional hardware and configuration. With VLAN, the functional role of the router is reversed. Rather than being used for the purpose of inhibiting communications, it is used to facilitate communications between separate VLAN as needed. Okay, so previously we used the router, okay, to segment the broadcast domain. Okay, but in this case, when we segment it, okay, they can't communicate to each other. Okay, from one VLAN to another, they cannot go through. Okay, so in order for that, okay, so using the router now, okay, need to facilitate the communication between the different VLAN. So virtual work group, okay, VLAN can be deployed like a virtual work group. So work groups are logical unit that commonly share information, such as a marketing department or an engineering department. So you can differentiate the VLAN between this PC based on the staff that is working for them. Okay, so which department, and then we group them together. Okay, as the same VLAN. VLAN also allow for switches to be quickly reconfigured so that logical network alignment can remain consistent with workgroup requirements. And also it enable the security where hosts on one VLAN cannot communicate with hosts on another VLAN unless some networking device facilitates communication between them. Okay, so we don't want the interference, or some of the application need to be specific for a certain department. The best is that we use a VLAN. Okay, now router. Router examine the network address field, which is on layer 3. So that's why we call it as a layer 3 device. And also router determine the best route for a data packet, as I mentioned before on the first slide. Okay, so when we determine that the packet, okay, has been received, and then it is meant for that router, so the router will check on the layer 3 what is the destination IP address, so they would decide the best route for that packet. Okay, so by using this, it will reduce excess broadcast traffic and latency. Okay, so because of only the router would stop this broadcast domain. They segment it. Okay, because of for the next hop, okay, or for the next network, it is on a different network, and then they are the one that the connector that would bridge to the next network. It also make internet working possible by interconnecting both LAN and WAN. So router have both ports for LAN and WAN. And then it's also act as a gateway. So sometimes when you type ipconfig/all, okay, let me stop this slide first. Yeah, I'll stop sharing and then escape. Okay, now let me go back to this one. Let me share first. Okay, now if you use the command prompt and then you type ipconfig/all. All right. So in every Ethernet adapter, okay, as you can see this one, okay, this is my Ethernet adapter. You could see the default gateway here. Okay, subnet mask, and then, oh no, this is not adapter 11, this is a virtual box. Virtual box. Okay, this is my wireless LAN local area network. Okay, the one that is having my IP address 169. This one. Okay. This one, as you can see, okay, this is an example lah. This is an example of one of the interfaces that I use in my computer. I have my virtual adapter lah. Okay, virtual adapter. So I have my own IP address, and then I have the default gateway. Okay, I must have the default gateway. So not this one. Okay, not this one. Link local, adapter, no, VNet, VMnet. Ni. This one. So my default gateway is 192.168.1. Okay. And then this is my IP address. So you should be able to see it. Okay, on your on a common prompt. Okay, what will be your router IP address? So this is your gateway, like a gate to go out to the internet, right? So this is how you want to know which IP address that you are using for your router. Okay, now let's go back. Okay, now a router is like a telephone system where each computer is given its own unique number by the router. So the information comes in, identified and processed, and then is sent along to the correct locations. So along the way, the decisions to take place behind the scenes in order to determine which is the correct computer to connect with. So there are more control options built into a router compared to a switch, including networking equivalents of call screening and caller ID. Okay, so the network router is a device or a piece of software in a computer that forwards and routes data packets along networks. Okay, in an early technology, actually the router is a part of a software inside a computer. So you can create a router functions inside a computer. Okay, provided that you have enough network interface device and network interface card. Okay, so it's because of the features of a router itself. Here you should be able to see there's a lot of ports needed. So a network router must connect at least two networks, commonly two LANs or ones, or a LAN and its ISP network. So means that from the internal to the external. So at least the minimum ports that it needs is these two. So a router is often included as part of a network switch. And sometimes you do have in your home like a Wi-Fi router, right? So the kind of thing that connect your wireless LAN, okay, but also help to route your packets, okay, to the modem. Okay, so a router has two key jobs. It will ensure that information doesn't go where it's not needed. Okay, they just determine where is the route, okay, that they need to forward. So no broadcast. So this is crucial for keeping large volumes of data from clogging the network. So that's why they avoid the broadcast here, because broadcast would incapacitate or congesting the network. So the router makes sure that information does make it to the intended destination. A router joins the two networks, passing information from one to another, and in some cases performing translations of various protocols between the two networks. It also protects the networks from one another, preventing the traffic on one from unnecessarily spilling over to the other. So this process is what we call as routing. Routing is a function associated with the network layer, layer 3 in the OSI model. So the router would use network layer protocol headers such as the IP header, where the source and destination IP address are included, and routing tables to determine the best path to forward the packets. For the communication among routers and decide the best route between any two hosts, routing protocols such as ICMP are used. My mistake. This was not the ICMP. Routing protocols such as RIP, EIGRP, OSPF, or other like not non-Cisco proprietary such as a BGP. Okay, so they use them. Okay. Now, not ICMP. Please correct this part. And then routers are specialized computers that send messages speeding to their destinations along thousands of possible pathways. One of the tools a router uses to decide which path a packet should go is a routing table. Okay, the one that I said about the routing protocol. So this routing protocol use the routing table to determine the routing route that they need to take. So it contains a collection of information such as information on which connections lead to particular groups of addresses. Also, priorities for connections to be used, such that, let's say we have an alternative route, okay, for that destination, then the router would determine based on the priorities. And then it also contains the rules for handling both routine and special cases of traffic. Information in the routing tables can be static, with routes manually entered by the network administrator. Okay, this is regarding the type of routing protocol that we use. If we use static, means that the network administrator must manually enter the route. But if you are using a dynamic routing protocol, okay, such as like RIP, EIGRP, BGP, OSPF, then it needs to be configured first by the network administrator, and after that, the router would determine itself, okay, will communicate to exchange the connection and route information using the various routing protocol. So because they have like a dynamic routing protocols, they communicate in between the routers, okay, to exchange the route information and the connection available. So a routing table can be as simple as a few lines in the smallest routers, but can grow to massive size and complexity in the very large routers that handle the bulk of internet messages. As a number, that's why sometimes the note here represent this is like a router. So as the number of networks attached to one another grows, so sometimes they connect to another router, and then connect to another router. Then the network will grows, okay, and the processing power of the router is increased. Okay, so that's it for the network component. Okay, so that's the most keys of basic component that is needed for a network. Okay, but there's other variations. Okay, but this is like a basic, and then there's a variation for improvement for from these basic devices. So next I'll go to the next one. All right. Ethernet LANs. Okay. So for this chapter, second portion. Okay, I would introduce about Ethernet LANs. No. Sorry. Carrier sends multiple access with collision detection. 10 megabit per second Ethernet, fast Ethernet, gigabit Ethernet, and the packet switcher technologies. So this will be different, a little bit different to the previous semesters as I upgrade the notes actually. All right. So please hold on because I cannot see my now I can choose my. Am I sharing it? Oh yes. Okay, where is my there is a. Okay. So what is an internet? It's an interconnection of individual networks. So to create an internet, you require an internet working devices such as routers and gateways. Okay, routers and switches actually. So in routers, switches, modems. Okay, all the things that needs to be to create internal and external networks. So internet is a generic term, okay, to mean an interconnection of network. Like a UTEM, we do have a small network that is interconnected together. So it's a small internetwork. I'm saying it as internetwork actually. Okay, look at the differences in between the second point. Big I, a big I internet, or I'm saying it, I call it as the internet is the name of a specific worldwide network, the one that you are using when you are trying to browse the website, Google, and everything else. So that's the internet. So the networking and internet working devices are divided into four categories: repeaters, bridges, routers, and gateways. So before I start with the Ethernet protocols, okay, so first is that I would like to introduce about the access method using the coaxial cable. No, the Ethernet protocols or the Ethernet networks. The cable or the media is shared together. Okay, so the media is shared together. So the way to access it, okay, we call it as CSMACD. This one, carrier sends multiple access with collision detection. So how does it works? So first is that in order for a host to send out a packet, okay, so it will start with a K20, and then it will sense the carrier. Sense the carrier means that they will sense inside the medium. If it's idle, there's a signal that is very similar to idle. Like if you, I'm not sure if you have experienced this. If you pick up a telephone and a traditional telephone, there's a buzzing sound, right? So that's the meaning of the sound of the idle. Okay, so the host would sense the carrier if it's an idle or not. So if there is some like intermittent signals, okay, so the intermittent signals are like an ECG, like a pulse. So it means that the carrier or the medium is busy. So it would use a one persistent strategy, like a waiting time, okay, and then set it back again. Okay, so it will remain sense the carrier until it is not busy. So if it's not busy, then it will wait for IFG time. So then it will send the frame. The IFG time is um the one that I have mentioned on the last chapter, okay, where we send the ARQ, okay, we just need to send out the time, okay, so we set up the time to wait before the frame can be acknowledged, just like that. So that kind of thing of IFG time, then we can send the frame. Okay, so after that, they would send if it's a collision or not. Okay, so if it's yes, okay, it will send a jam signal and then increment the K. Okay, so K will be multiplied by it will increment by the K dot 10. Okay, and then if it's yes, K is equal to 10. Sorry. If it's K is equal to 10, then it will abort, but not, they would wait back of time, okay, and then send back again, and then wait back again. Okay, so but if there is no collisions, then it is a success. Okay, so that's how the CSMACD works. Okay, so and then in the Ethernet, okay, the layers in the data link layer is made of two sublayers. One is the logical link control or LLC, and then the second layer is the media access control. And then in the physical layer, it consists of four: physical layer signaling or PLS, attachment unit interface AUI, and then medium attachment unit or MAU, and then medium dependent interface MDI. So the protocol 10 megabit per second Ethernet follow the OSI model such as this. Okay, inside the MAC sublayer, it's responsible for the operation of the CSMA CD access method. The frames data received from the LLC layer and then passed to the PLS sublayer for encoding. The PLS is on the layer 1. And then IEEE 802.3 MAC frame contains the 7 fields here. Okay, it will have preamble, SFD start field delimiter, destination address, source address. This one is the MAC address, because this is on the second layer. Okay, and then length of PDU, and then what it contains is a data embedding. Okay, data embedding like DSAP, SSAP, control and information. Last one is the CRC for the error and correction control. So Ethernet does not provide any mechanism for acknowledging receive frames or known as an unreliable medium. So Ethernet doesn't have an acknowledging. So they just use the timer. Okay. So that's why it's known as unreliable medium. The addressing using the Ethernet address is a 6 byte or 48 bits. Okay. You can look at your IP config, okay, and then you can check your physical address. So it's the same as a MAC address and also the Ethernet address, written in hexadecimal notation. So remember, for the hexadecimal notation, it's from 0 to 9, and then continue with A, B, C, D, E, F. Okay, so if you cannot remember about hexadecimal notation, you need to learn back again about this number system. And then the address transmission is conducted from left to right. Okay, so the transmission start from left, 07, 01, like that. Okay, from left to right, byte to byte. Okay, so the address transmission is from byte, using a byte. So from the left byte to the right byte. And then the least significant bit is sent first and the most significant bit is sent last. So in this case, okay, 07, 07, the octet for the first octet 07 is represented using a binary 0000 for 0, bit 0 here, and then 7 here, okay, to represent hexadecimal number 7 here. Okay, 7 bit 16. So, but for the transmission by bit, okay, when they send it, it must be in a bit, not by byte, okay. So when they send it by bit, they send from the least significant bit, in this case this one, okay, and then the next one, the next one, the next one, until it reach to the most significant bit. So this is what it meant here. Okay, this least significant bit will be sent out first, this bit, and then the next one, the next one, the next one, until the most significant bit, which will be sent lastly. Okay, so the same happened on the for 01. So bit 1 here will be sent out first, and then 00000. Okay, the same thing. Okay, right. Unicast and multicast address. The source address always a unicast because the frame comes from one station. Okay, when you want to send out, okay, you want to request a services to a server. So usually, okay, it's targeted. It's the source comes from one source only, but the destination can be unicast and multicast. So, unicast destination only define only one recipient. Okay, the relationship between the sender and receiver is one-to-one. One-to-one, like your computer to Google. Okay, or to UTM Ulearn server. Okay, so that is one-to-one unicast. So for unicast, okay, the destination, okay, the first bit transmit is 0. Okay. And then for multicast destination address defines a group of address. The relationship between the sender and receiver is like one to many. And the first bit transmitted, okay, in the byte, on that byte, the first bit that is transmit for multicast is 1. Okay. So that when they process it, they will know this is a multicast packet. Okay. And then globally unique address and locally unique address. Globally unique address is unique for LANs, where it can be accomplished if all manufacturers agree to follow the same rule. Okay, so in order for to communicate, okay, to each other, okay, from one end to another end, they must have a globally unique address. So that's why the manufacturer agrees to follow the same rule. But for a locally unique address, the vendor does not follow the IEEE rules because they sometimes have their own unique address, okay, for their own network. And then physical layer in 10 megabit per second Ethernet is made up of 4 sublayers: PLS, AUI, MAU, and MDI. This is a physical layer, right? So 4 layers. So for the physical layer signaling, it's a common for all implementations. And then they sometimes may or may not have attachment unit interface or AUI. So some may or may not present in some of the implementation. And then medium attachment unit or transceiver. Okay, it's a very specific, depends on the medium dependent interface. So it must connect together. Like a BNC must connect to a copper receiver. Okay, so they must be connected to each other. Okay, depends on the transmission medium that you use. Okay, in the physical layer, sublayer, okay, signaling sublayer, they encodes and decodes the data. Okay, so because of the standard is a 10 megabit per second, so they use Manchester encoding with 10 megabit per second data rate. And then for 10 megabits data rate, Manchester encoding needs 20 MBouts bandwidth. Okay, so for from the MAC to the transceiver, so they use a Manchester encoder, and then from transceiver to MAC also they use Manchester encoder. Okay, and then attach AUI. AUI is the interface in between PLS and MAU. So the interface was designed for the first implementation of Ethernet using a thick coaxial cable. Okay, so they have a connector between for the MAU, okay, to the cable, and then another, okay, for the PLS, there's another port and then connected to the cable. So this AUI cable is needed for external transceiver. And some of the cases, AUI cable is not needed for internal transceiver. AUI signals contain 4 types, can be defined in as a transmit, receive data, collision, presence, and power. Okay, so transmit data, you know, it carry from network interface card to transceiver. Okay, using the Manchester encoding, and then also the same for the receive data. Collision present is a signal sent from transceiver to interface card when there is a collision on the line. Okay, when they sense it, they sense the collision presence. And then power provided by the interface. Like your cable iPhone or your cable for your charging. Okay, some of the cable is capable of transmitting the data and then also have the power. Okay, so it's the same thing. Now, this is what it looks like for the AUI connector. Okay, it's a 15 D connector that consists of transmit, receive, and then collision power. So each of these pin is responsible for a certain um signals. So for a network interface card side, they use a male connector, and then to the transceiver side, they use a female connector. So there's a difference. This one is like a pin here. There's a pin here, and then this one contain like a 15 holes. Okay, and then MAU or medium attachment unit or transceiver create an appropriate signal for each particular medium. So the transceiver transmits signals over the medium, and it will receive the signal over the medium besides detect collisions. So it can be internal and external transceivers. Okay, so there are several categories of 10 megabits per second or baseband Ethernet. So the IEEE standard defines 4 different implementation for the baseband, such as 10 base 5, 10 base 2, 10 base T, and then 10 base FL. So for 10 base 5, they uses a bus topology with an external transceiver connected via a tap. We call it like a tap to a thick coaxial cable. Okay, the tapping here means that the signal can be interfered. Okay, so the signal can be interfered or the can be shared together. Okay, so for the transceiver cable, the maximum must be in 50 meters. And then for the backbone, maximum is 500 meter. Okay, so a maximum of 5 segments can be created using a 10 base 5. With each segment is a maximum of 500 meters. So 5 segments, 3 useful, so considered as 2,500 meters. Okay, so the 3 segments can be used for connecting nodes to medium, 2 segments for repeater. Okay, so from segment 1 to segment 5, in between of a segment 1 to another segment, and then from segment 5 to another segment, we use 2 repeaters. Okay, and then maximum nodes is 300. 3 useful segments with 100 nodes per segment. Okay, so for each of these segment, they can contain 100 stations. So let's say we have 3 useful. Okay, 3 useful segments. Then we have 300 stations. Okay, so 10 base 2 or thin Ethernet or cheaper net, they uses a bus topology the same. The same as the thicknet, the previous one. Okay, so this is the configuration, the same, maximum 5 segments, but the maximum is 185 meters. 3 segments can be used for connecting mediums, then 2 segments for the repeater. So only 3 useful. Okay, maximum nodes is 96. 3 useful segments with 32 nodes per segment. So it times 32 nodes per segment times 3 means that 96 stations. Okay, for 10 BST or twisted pair Ethernet, they uses a physical star topology, but logical topology is still bus. Okay, so physically it's a star topology, but logically it's still a bus topology. Yeah, nodes are connected to a hub. Okay, with either an internal or external transceiver. Okay, because they are using a hub, they are sharing the cable together. Okay, so the interface card is directly connected to a medium connector when the internal transceiver is used. Okay, so this external transceiver is connected to the repeater hub. Okay, and then from another here will be connected using a UTP cable. Now, 10 base T twisted pair Ethernet, okay, required 2 components, twisted pair cable and RJ45. Maximum is 100 meter. Maximum node in a segment is 2. And then they use 8-pin RJ45 jack with female and male connector. Okay, for 10 base FL is for fiber link Ethernet. So it uses a star topology nodes that are connected to a hub. It's implemented using an external transceiver called fiber optic MAU. So the nodes is connected to the external transceiver using AUI cable, and the transceiver is connected to the hub by using two pairs of fiber optic cables. The two components for twisted pair Ethernet fiber optic cable, and then also need a connector. Sometimes they use ST. Okay, so the fiber optic cable is defined for 10 bits FL, is a graded index multimode cable. So a full duplex with the maximum length is 2000 meter or 2 kilometers. And then ST connector is a common type for fiber optic medium. So the data link is made up the same thing. Okay, for the fast Ethernet. Okay, the same thing for the data link layer, they use a logical link and media access control. But for the physical line, they have four layers: reconciliation, medium independent interface, MII, PHY, and also MDI, medium dependent interface. Um, Fast Ethernet 100 megabit per second are similar in frame format and then minimum and maximum frame length and addressing. The only difference is in the time slot in seconds and the maximum length of the network or the collision domain. So the new features in the fast Ethernet is that they have auto negotiation. So what is auto negotiation? It allows two devices to negotiate the mode or data rate of operations. It's designed for allowing incompatible devices to connect to each other or to allow one device to have multiple capabilities. Okay, and also it will allow a station to check a hub's capabilities. Two devices connected can negotiate their capabilities. Okay, using this auto negotiation. So the negotiation can only occur during the link initialization. So this negotiation uses a separate format and signaling system. So each device would advertise their own capabilities. So for example, for this station, it has half duplex, but the hub here has a full duplex. So the decision is based on common capabilities. The hierarchy of common capabilities is defined to facilitate the decision. Okay. The message format. Okay, it's a size of a 16-bit messages. Okay, they have a selector, they have ability, and then fault, next page, and then acknowledgement. Okay, and then the field consists of 5 bits of selector, technology, ability, 8 bit, remote fault, 1 bit, acknowledge 1 bit, and the next page 1 bit. Reconciliation replace PLS on the 10 megabit per second fast Ethernet. And then the responsible for the reconciliation is responsible for whatever is left over, specifically the passing of data in a 4-bit format to the MII, medium independent interface. AUI was replaced with the medium independent interface. MII, in fact, is an improved interface that can be used both on 10 megabit per second and 100 megabits per second. The medium interface, medium independent interface is connected to the PHY or physical layer entity transceiver. And then here it will connect to the medium dependent interface or MDI. Okay, MII features. It operates on both 10 megabit per second and 100 megabit per second. It features a parallel data path of 4 bits at a time between PHY sublayer and the reconciliation. Okay, so if it's an internal transceiver, MII is not needed. Okay, so what is inside the MII signal? It has signal for transmit, receive, control signal, management signals, and also power. Okay, so this is what it looks like, the pin for 100 megabit per second. It's a 40-pin D connector. Okay, it contains 20 twisted pair cables to carry signal between Ethernet interface and the transceiver. So on the NIC side, we use a male connector, and on the transceiver side, we use a female connector. Okay, so let's stop at these slides. Okay, for the praying. Okay, we need to stop for the praying. All right, so it's 7:10, and then it's a praying time. So I'll stop at 7:10, and then we may continue, inshallah, maybe 7:30, or maybe 25 minutes again, 7:35. Okay, all right. So I'll pause this. Yes. I'll pause our lecture first. Okay, for the break. Okay, for praying break. So and then we will continue later. Okay. Thank you. Stop sharing.